Alright class, now that you have tried the examples on your own, we want to go ahead and talk about this together just to make sure you guys are comfortable before you come in the morning. The first example says name the type of each segment or line, and some of these are segments, some of them are lines, and that will help us kind of narrow down what vocabulary term we're looking for as well. So let's start with AH. AH is a line. They tell us that we're looking at line AH. We notice that it has one point that's on that circle. That one place that it touches the circle, that is called our point of tangency, making this a tangent line. So line AH is a tangent. Now, segment EI, we notice that it's a segment. It has two endpoints, and those endpoints are on the circle. But this segment also contains the center of the circle, making it the diameter. Segment DF also has 2 points that are on the circle, but it does not contain the center of the circle. So when we've got a segment that has 2 points on the circle but not the center, that's just considered a chord. Now, the diameter is an example of a chord, but it's a very specific type of chord that we refer to as just the diameter. Segment CE, going from the center to a point on the circle, is called our radius. And line HG, the line that goes through the circle at 2 places, because it's a line, it's not just the segment, we call it the secant. Alright, moving on to our next example. It said for each one of these we were going to give the center and the radius for each circle. So let's start with circle A. When we're looking at circle A, the center of circle A is a point. It is a point that is equidistant from every single point that's on the circle. And notice that ordered pair of the center for circle A is going to be at 3, 3. Again, it is just a point. Now the radius is not just a point. The radius will be the distance from that center to any point on the circle. It's usually easiest to take a look at the either horizontal or the vertical distances when you're counting these, because then we can just count units rather than having to try to figure out distance formula and where those points exactly are. Notice that it's 1, 2, 3 spaces from the center to that point on the circle, so the radius here is 3. Now, circle B. Its center is located at the ordered pair of 3, -3. And its radius, if I count its distance from that center to the circle, there's 1, 2, 3 spaces. So that radius is also 3. So we have 2 circles here that have the exact same radius. That means that these are an example of congruent circles. They have the same measures. They would have the same areas. They would have the same circumference. They're congruent circles. Now, if you take a look at them, they also happen to intersect. The next question talks about their intersection. They intersect at one point. That intersection is the point of 3, 0. That's that one place where they touch. Notice this would be an example of tangent circles, 2 circles that intersect at just that one location. And they also ask us to describe all of the common tangents. So let's take a look here. There's one tangent line that's already drawn in for us. This red line does intersect both circles at just one point. The equation of that line, because we're talking about describing a line, we want to list its equation. We notice that it is a vertical line, so we're thinking vux. It's x equals 6. There's also going to be a common tangent on the other side of that circle. If you take a look here, right along the y-axis. Right along the y-axis. Oh, goodness. We notice that that's also a common tangent. That would be the line x equals 0. There's also a common tangent that would go through that point of tangency that those 2 circles would have in common, and that equation of that line is now a horizontal line, so y equals 0. So we have really 3 common tangents. This y equals 0 would be an internal tangent. It's going in between those circles, where the other 2 lines would be external tangents.